Hey everybody, in this video I'm going to talk to you about the bell ringer that we talked about in class yesterday for 5th period. And this is your bell ringer for today's class. You're going to turn this and the other bell ringers in since Friday of last week into the sub. So you are watching this video after you have watched Tyler DeWitt's Half-Life intro video. So let's take a look at these questions. Number 1 and number 2 here, a radioactive isotope has a half-life of 2,500 years. How many years is 5 half-lives? And number 2, carbon-14 has a half-life of 5,730 years. How many half-lives occurs in 17,190 years? So write these down, leave some space, and try them out for a few minutes with your, with your team members, and pause the video, and we'll go from there. Okay, so number 1 is very similar to the thing about the oranges I said in class the other day on Monday. If you have every orange is $1, right? Oh, let's just say 1 orange, right? Not l'orange. 1 orange. And how much would it cost if you had 5 oranges? Right? And so that would be $5 because you're just multiplying. So here, if 1 half-life is 2,500 years, so 2,500 years is 1 half-life. So 2,500 years per half-life, right? It's like 50 miles an hour, 50 miles per hour. And then you multiply it by 5 half-lives. And you notice that the half-lives is on the bottom of the fraction. Here it's on the top of the fraction, right? Any number over any is by itself over 1. So the half-lives here on the right is on the top, and here on the left it's on the bottom. So they cancel out, right? And it's 5 times 2,500 is 12,500, and you have the units here, years. So that's how you solve this. That's the most basic question here. On the second question, you have the given, which is 5,730 years per half-life. And you have 17,190 years. Now you want to cancel the years, right? And you want to have your half-life as your answer, right? That's what it says, how many half-lives. So we need to divide it in a way that's going to get us the answer that we want. So we want to cancel the years. So the way you cancel years, put years on the top and years on the bottom. So what you actually do is put 17,190 years right there. And notice years here is on the top and years here is on the bottom of this fraction here, right? That fraction right there. So the years actually cancel out. Now, when you do that, you're going to get 1 divided by 1 divided by half-life. Now, through a mathematical manipulation, it's 1 divided by 1 over half-life is the same thing as 1 by multiplying this number's reciprocal. So a reciprocal is, remember, flipping the fraction around. So it's 1 times half-life over 1. And of course the 1's cancel each other out and you're left with half-life. So this has come up before. This has come up before in this class when we did density. So when you did mass divided by density, right? Grams over centimeter cubed. The grams cancel out because the grams are on the top and grams are on the bottom, and you're left with 1 over centimeter cubed, which is the same thing as multiplying by the reciprocal, which means that you get centimeter cubed, which is the volume, right? Remember that to solve for volume, it's mass divided by density. So one way to solve all these questions that especially we're going to get in the second semester is you could memorize equations, or you could just follow the units so you can cancel the units you don't want out to get the units you do want. So you see here that the units that you want to get rid of are the grams, right? Now you have ones left. Dividing by a number is the same thing as multiplying by its reciprocal, and the reciprocal of 1 over centimeter cubed is centimeter cubed over 1. And then you're left with the thing that you want. So if you go back over here and you see, oh, I have 1 over HL, right? Gets you HL. So another way to think about this is if you have 1 over 5, think about what that answer is in your head. Write it down. Yeah, the answer is 5. So 1 over 10 to the 6th is 10 to the 6th. So hopefully you got that right. So now I'm going to go over number 2 on the calculating half-life of radioactive isotopes worksheet. And so, new slide here. So you're given that you have 50.0 grams starting out, right? So the way we write that is an amount, the initial amount. So you put A0 at starting time. And at the ending time, you have 12.5 grams. It says this happens in 14.4 seconds. So it wants to know what is the half-life, right? T1 half, that's how you write half-life. So if you read the question number 2, it says a 50-gram sample of nitrogen-16 decays to 12.5 grams in 14.4 seconds. What is its half-life? So all I've done is I've written out the variables so I don't have to read the question again. So remember, half-life is the time it takes to take half, right? So you have to go from here to here. How many halves did you have? So you notice that it's 50 to 25 is one half-life, the first half-life, and the second one is 25 to 12.5. So we know it takes 2 half-lives to get to 12.5 grams. So you take your number here, you think about it takes 2 intervals to get to that. So after one half-life, you're going to have 25 grams. And after 2 half-lives, you're going to have 12.5 grams. So, and we know that is at 14.4 seconds. So what is the number that gets us there? So we just do 14.4 divided by 2. Because it takes 2 half-lives. And that, so because it's 2 half-lives, right? You see it's seconds over half-lives. So it's 7.2 seconds per half-life, which is what we're trying to solve for. What is its half-life? So remember, after the first half-life, 7.2 seconds, you have 25 grams left. After 2 half-lives, 14.4 seconds, it's 12.5 grams. So that's how you do number 2. So work on the rest of them for homework, and we will do quiz review on Thursday. Thanks. Have a nice day.